Hello everybody. So this time around we're going to talk about gold in Utah. Where is gold in Utah? By popular request, or rather demand, or rather I was barraged with queries for gold in Utah. And there's substantial reason for asking that question, because there are places in Utah where there is gold and there are places where there is not gold. And of course the ultimate question we always ask when we're looking for gold is, what kind of geologic features are going on in the area that will lead us to see where we're likely to find gold and where we might not be so likely, or where we'll have to use special tricks or techniques to find gold. So let's take a look at what's going on here, because it's kind of interesting. First thing I wanted to do is take you over and let's see if we can do this in one fell swoop. So one of the things that I wanted to show you was a little bit of unique characteristic. This is a map by the USGS that kind of depicts the different rock structures and ages and kind of what's going on in terms of the actual rocks and minerals that form the geologic history of the continental, well, actually of North America. Okay, this includes Canada and Mexico. So what we're talking about here is, do we have information here that might help us understand a little bit of what's going on in Utah? And indeed we do, because when you look in this region, you'll see this. Remember we talked about Horst and Graben. That's this kind of grayish looking area over on the western side here. Let me shift this over to the other screen for the moment. This area right in here is the area we're talking about with Utah. And so what I'm doing is kind of circling this in blue. I don't know whether you can see it or not. But you notice how right down this line here, there's a change from this Horst and Graben on this side to a different kind of terrain heading on the east side. And that is basically the base mountains of the Rockies, or the Cordilleras is what they're called. The Cordilleras are this yellow stripe that run all the way down the Rockies and down Mexico and continue on down into South America. It's the backbone of the North American and South American continents. It's the thing that makes the mountains rise in the middle. So for information, on the west side of that is our Horst and Graben structures, the things we've been talking about all week, and I'll go into that in a second here with the Utah map. But what we're looking at on the east side, though, is something new, and that is this crushing relief map that generates the Rocky Mountains. And that's a very different animal entirely, and requires a different kind of study. But it has an impact on the amount of gold that's available to you east of the mountains in Utah. So when you go above Salt Lake City and into the mountains, you're going to get a different kind of terrain from there on east, heading toward Denver, Colorado, for example. So let's take a look. What's going on here? So that's kind of that picture. I don't know whether I can, well, let me change colors here just to kind of give you a better picture of what I was trying to draw. So this is the dividing line here, right down through here. And heading east, you're going to go into this yellowish stuff. And heading west, you're back into the thing that goes from the Sierra Nevada on across. And that's the Horst and Graben, or what we call basin and range type topology, where things are bouncing up and down in these up thrust fault blocks and down falling blocks, back and forth. And that makes that crushing, remember we talked about accordion pleated effect. That accordion pleated effect is really, really desirable when it comes to finding gold, because it's going to buckle up all kinds of hydrothermal deposits and mineralizations in the rocks and minerals that are normally stored several miles down in the alluvial stuff. That's part of the problem you'll see. I'll show you in a second here in the Painted Desert area, southeast Utah, because you run in northeast Arizona. You'll see that there's so much alluvial material that it covers up any gold. Anything that might be in the area would typically be flood gold. So let's take a look. Go back over to our and don't forget to check out that Gold Diggers Underground thing. It's still available, so take a look. That's this thing right here at sourdoughminer.com/GDU. Just go take a look. Watch the video. So Oh, and by the way, the GDU, one thing I wanted to point out, somebody pointed out to me the other day, I mentioned there's a trial. The trial's dirt cheap. It's like $1. So, you can't lose. It's a 14-day trial. And you just kind of, see whether or not you're interested. If you're not, just say cancel. And that's it. No questions asked. So I just wanted to make sure you knew about that aspect of it because I forgot to mention it earlier. So let's take a look. In Utah, we have this series of mines throughout the western part. Again, we're talking about the Horst and Graben thing. So here we are. We got all this material up and down. I'm going to go try another thing here. I'm going to add another whiteboard to this one too. I found out I can draw whiteboards on top of these pictures, which might help draw things out. So let me put it on here. And now, set the color to something useful, like, I don't know, how about iridescent green? That would be good. And set the size to jumbo. And here we go. So now, what I was talking about earlier is sort of see this black line going down here. This is the mountain ridge that draws and divides Utah pretty much into two parts. Notice on the western side, we see lots of gold prospects. That's the yellow X's here. And on the eastern side, we don't see so much until we get over here to the Rocky Mountains that cut through here. And so what happens is, as I mentioned, there isn't much to the east, except in particularly exceptional places where the mountains kind of skew sideways a little bit. These are transverse ranges, they call them. They happen on a globe because, again, it's one of those properties of when something buckles up and it's going around a globe, every so often it has to translate or create a transverse fault relief that causes it to crack. Kind of think of it as shattering glass. It doesn't shatter in a straight line. It shatters in any direction that will relieve the maximum amount of stress so that it can follow whatever curve it's being forced to. And in this case, it's a sphere with pressure on each side. So as it cracks, it tends to go along a nice, relatively linear S-type curves, but every so often it'll cut sideways. You'll see that in Southern California with the transverse range here. Goes basically from San Bernardino all the way out to sea past Santa Barbara. And so when that happens, that releases a bunch of that stress that's pent up from the Sierra Nevada and the coastal ranges being upthrust. Same thing's going on here in Utah. And so you've got another range heading due east right here. And lo and behold, when that stuff gets upthrust, you start finding more gold along the edge of it. But out in the middle here, where there isn't so much upthrust, not so much gold. Now that isn't a hard and fast rule by any means for gold, but it is one of the factors that plays into why you can find gold with respect to geology, and that is you're looking for these areas where there's upthrust and areas where you can find a distinct area of exposure where the gold appears to pop through that material. So that's important, pop through the surface. So if we buckle something, now we can see the layers below that might have gold embedded in them, and that's the whole objective with what we're trying to find. So let's go look at some of the particular mines of Utah. Oh, and here's the area around I was talking about earlier. This is the let me add another one of those things. I like those. I can draw all over the place with these things. So let me add another whiteboard to this picture. Change the color to fancy dancy radioactive green here. It's not to say anything about Utah and radiation, but so I don't want to hear about it, guys. Okay, got it? I mean, you clamored for this. You got it. This is Utah. So as I was pointing out, there's this whole section down in here. You need to change the thickness so that you can see it. There. So down through here and on into Arizona, this is all the painted desert here. And that has a lot of alluvium that's very interesting and loaded with iron and all kinds of other minerals that give it brilliant colors. Spectacular place to take a vacation. But the fact of the matter is, it also is a spectacular place to cover up all the gold down deep. And so what you're going to find here is you might find along these perimeters where there are gold prospects there may be some nuggets and things like that that you can hunt. But for the most part, they're going to be buried pretty deep in the sands and gravels that are in the areas and silts. And so not as easy to find as you might wish. So just keep that in mind when you're looking in this area. Now, that doesn't mean there aren't. And as you can see, generally they're going to follow, as we've seen over in this area, they're going to follow this kind of darkened patch on these pictures. I'm going to zoom in now. So let's zoom in on this guy right here. And we'll see indeed there are mountains here. In fact, there look to be volcanic type structures. Okay. Now, how do I know they're volcanic type structures? Well, they're conical. They go up as a cone, upside down cone. And so what happens is the volcano has a vent at the top and it builds a shield around it as it basically as it vents its materials out onto the crust of the earth. And so it leaves a cone-shaped structure, raised altitude, more precipitation, more vegetation, etc., and also more erosion. And with it goes these vents. And so indeed there are some vents and stuff up in these mountains. Now, I don't guarantee that that's what these are. They just have the appearance of being conical structures and volcanic, which can also contribute to some of the colors you see out here. Because basalt, basically, when it oxidizes and degrades into these brilliant red sands and dirts you see all over the place. And so because it's mafic. Remember I talked about being ultramafic? Well, mafic is magnesium ferric. Iron turns red when it oxidizes. So when you see red soils, they're high in iron, usually. They can be higher in a few other things, but iron's the big one. So, and that's what I see over in here, is a lot of iron and that kind of mineral. Now let's take a look at this this region right in here. I'm going to zoom in. Now, of course, our fancy dancy thing needs to be cleared off because it makes no sense whatsoever. Let's see what these guys say up here. Might give us a hint about what's going on. Okay, gold and copper. So these have been copper production mines. And primary commodity coming out, that was gold. Tertiary is copper, number 3. Let's see what we got over here. Copper gold. So primary was a mixture of copper and gold. This is the South Bromide Basin. Bromide tends to speak of a salt, bromium. Basically, you get bromides and you get chlorides. We know the most famous one is sodium chloride, which is salt, table salt. But, you also get bromides in the same kind of regions in the desert. So, what is going on here? Let's take a look closer. See if we can't see. Oh, look, there are mine shafts and tailings piles. Crescent Creek Adit. Remember I talked about the horizontal tube versus the vertical shaft? That's a type of mine that goes horizontally. And look at this. The thing they're pulling out here is copper ore in the form of chalcopyrite, and they're pulling out copper. It was a past producer and had as primary commodity gold, silver, and copper. Pretty cool. But probably in the form of chalcopyrite that could be reduced into gold, silver, and copper separation, chemically separated. The problem with most pyrites is you get into, they have to have a certain amount of purity in the proper mixtures to be worth reducing out because of the chemical and or the heat involved. It can exceed the value of the material inside, although with gold up where it is, and copper too, it might be valuable no matter what. But it's an interesting thing. Let's see if we can see the adit itself from the air. If we zoom in here, we might find an entry shaft or something funny. Pretty hard to see. Lots of trees down here. It's kind of odd. Almost like a blowdown, but it doesn't look like a blowdown, so I don't know whether they were thinning or what. It does look like there is mining operations going on right here, and some kind of treatment material structure here. gravel pit like they're pulling rock out. See, a lot of times they'll have an adit, they'll go in, and if this thing starts to produce, it might be more productive to actually just rip the whole structure down from the top down if it's not very deep. So once they find out where it is, then they'll blast and remove the rock and start pulling out the gold pay dirt. You've seen this on Gold Rush if you've watched that show. But, you know, they'll go in and find something, and if it has enough value per ton, and the material in between you and wherever that value is not too significant, it could be more inexpensive to take off that surface rock material, all that overburden, and remove it, and basically create yourself a big gravel pit, crush this stuff up, and reduce the gold out using various techniques such as the cyanide treatment, which is one method of pulling gold out. You do what they call a cyanide leach. You take the stuff, you crush it down using a rock mill, and then you produce a powder that's very fine. You lay it down in layers, and then you use sprinklers with traps underneath that are siphoning out the fluid that leaches through. And below that is a layer to protect the earth from further leaching into the soil. And what you're trying to do is get all that leached material out, which percolates through all this crushed rock, and then out comes the gold mixed with cyanide, and then you use a certain precipitate process to cause it to precipitate out the gold and recover the cyanide, and you recycle it. Keep going round and round. So that's a pretty straightforward view of, you know, it can be a very complicated process depending upon what else you're doing. Like with sulfides, it can spoil that mix chemically, and so you have to do certain other steps to kind of keep things cooking. You also might have to do other steps just simply to get to the point where it'll actually release the gold from the lattice structure, the crystals and the minerals and the elements that are tied to it because of the chemical properties. It's a pretty fascinating chemistry, and I was talking with someone the other day about it here, and I thought, you know, we'll just do a special on that at one point. It will be a little overwhelming, I'll give you a caution up front, because it's pretty complicated in terms of chemicals, and it's pretty complicated in terms of step, but I like it because I'm background in chemistry, but also because it's just fascinating to watch the process. It's kind of like a big pachinko machine, you know. This side produces this you know, precipitate, this side produces some kind of fluid and solution of gold and something else, maybe some platinum or whatever, and then each stage brings out the next thing. It's kind of like how they bring oil into a plant and bring out gasoline and avgas and jet fuel and everything else and tar for your roads out the other side. So similar properties going on here, but it's all metals. So that's that one. There do seem to be several different places they've marked on here: Bromide Basin Mine, silver, copper, gold, past producer, bornite, chalcopyrite, gold, malachite, quartz. Malachite is a copper ore. It's also a gorgeous, you know, gemstone in itself if it's good quality. It can be polished and turned into those gorgeous green beads and things like that that people like to collect and pay good money for. So there's some value in terms of a specimen quality. Here's some more gold and copper. So that's it for this area out in the Painted Desert. Let's go to the west for a moment. Let's go out to this edge along right in here. So what we're looking at now is on the border of Nevada. And remember, Nevada was dotted with gold all over. So my suspicion is, again, because of this trend line over here, let me draw on the map. So you can see these trends coming down through here that look like this. One here, one here, one here, one here. And what I'm following are these mountain ranges that are sort of sticking out of this mess in dark relief. And these are the basin and range things, and these are the general trend lines for the gold to come out. They'll follow these lines. And so again, on the west side over here, the dominant geology is going to be looking at these ranges and spotting gold mines that follow the trail. And what I see right now is, I'm going to change colors a little bit here. I see a pile of gold through here, and then I see more up in here, and some more in the pile over here, and pretty much nothing much other than a little spot right in here with this ring of gold. So that's kind of the areas that you're going to find the most gold in that part of Utah. Let me zoom back out a smidge, which is going to totally mess up the chart I just drew. Because I probably should have done this in the first place. Clear. So again, we talked about a bunch of gold through here, a bunch of gold down in here, and these are dominated by that uplift down thrust, blocks, and the mountain range down here. So we have the uplift down thrust blocks kind of coming through these regions. Maybe a smidge up here. Now this area right in here, Salt Lake. So again, we have a large amount of sedimentation. Overlaying that sedimentation, it would be a large amount of sedimentation because it's terrifically flat. That's what happens when you get a lake that fills in like Salt Lake. What it's filling in with are salts, and those form a temporary dry lake during seasons, and then at other times, as weather permits, the stuff dries up and the lake disappears. That's what's happening over here. The Salt Lake used to be a great big huge thing, and now it's just this little pond over here. So which by the way is probably changing as we speak, because what happens is when we get these seasonal things, especially when we get El Nino with the atmospheric rivers, and we get global cooling happening with the situation that's happening with the sun and the decrease in sunspots and decrease in thermal activity coming out of the sun, all of a sudden you have this extra precipitation, extra cool weather, not so dry. Boom, this lake will fill up and those salts will dissolve in the water. Now, what does all that mean? Well, it means there's a big layer of stuff on top of any gold that might be in this region for the most part, and the only place you're going to typically find it would be in areas where, and I'm going to erase this board again. Let's zoom into that area just for grins. So notice what I see. Where the gold is found for the most part is up where the rocky passes are poking through the salts, or on the edge of them, like right here. And so the Pocahontas group, belonging to one of our, never mind, I wasn't going to go into politics. So gold, okay? So this guy has gold in it. Let's see what the record says about it, just for grins, real quick. Salt Lake Mineral Review in 1924. So there we go, a 1924 record again. I just wanted to check to see what kind of time frame that record came out. So a lot of these are older deposits and probably haven't been exploited for a long time. I notice they don't show any, in terms of the mine. You have this feature right here. Never mind. You can't really see on here the effects of mines being open, which is upturn picks, mines being closed, which is downturn picks, and then X means it's in current, a prospect, or we don't know whether it was ever a mine, or we just have some data here and a data point, a place that said gold. So looking at this, you can see how much the Great Salt Lake has decreased in size as it shrinks. You can also see how the salt basin out here, where they do all the racing and all that good stuff, has increased. This is an oddity, Clifton, silver, gold, lead. Why this guy is out here, I don't really know. Clifton Mining announces discovery of new mineral structures. 1997. Hey. Now there's an interesting thing. So somebody found something and reported it right here in this report in 1997. I'd call that recent, guys. And what I would want to do is find this report and read up about it to understand what they're finding, because oftentimes when they make discoveries, lo and behold, oh, that didn't work so good. When they make discoveries like this, it has an effect in the immediate area. So this is maybe an experimental process or mine that might have some indication that they, pulled some of the salts out and tested them for gold. I mean, that's as simple as it could be. And they have some new process they're using to reduce gold out of salt. I don't know. Or we're just, who knows. But it would be worth kind of investigating, because I'm just that kind of person. I like to dig into things like that. They have puzzles to solve. So that's it for tonight in terms of this area. There was one other area I wanted to point out to you. Again, the Painted Desert, kind of sparse down here. There is this area down in here, again, mostly along Nevada border, the prospect south of the Jenny Mine, gold and silver, and so forth. St. George has a little bit of gold here in the Dixie Mine, primarily copper, gallium, and germanium. So these are basically semiconductor kind of materials that are used in industry, and could be of value in that sense. But primarily it's going to have a lot of lead, zinc, arsenic, sulfur, and so forth to go with it. And so it's interesting that it has this copper, lead, zinc. BC name is carbonate hosted copper. So that's kind of interesting for that one, but it's an oddity in a sense because it's kind of orphaned out here in St. George. Now I wanted to do one more thing with this just before we leave, and that is, let's take a look at what this looks like when I turn on Arizona. So one more second here, guys, bear with me. And I want to know in the comments below, tell me if you're up for a double header tonight. I thought about hitting Texas next. And I can do that right now, or I can postpone that and do it tomorrow. But if you want to go for a little more, we'll break this one and we'll go on to doing another one immediately afterwards on Texas. So let me know, raise your hand in the comments and tell me Texas. Yes, Texas. Okay. So here we go. Looking at this guy and turning on the toolbar allows me to turn this back on. Now I can see what's going on in here in terms of these mineral resources databases. And where were you? There's Colorado. We just did that last night, so you can see how same properties hold through here. This band over here is following through. And that's something else you want to do with these maps. Kind of collect them. You typically find when people produce paper maps or a unique map online, you get it, you find one state at a time. You're not looking for the state, you're looking for the origin of the gold. And that doesn't follow state lines. It follows wherever gold wants to go, and typically these mountain ranges are it. So when you see something starting here, it's logical that it would go on across. Let me move this a little bit so you can see it out from under me. So it'd be logical that it would go right across and on into Colorado. Same thing holds true here. That's where I'm trying to head, is show you Arizona. There's Nevada. Remember we did it the other night. Got a little overzealous and included some extra gravel pits and stuff, but you get the idea. It's in there. Now we go along, we look at Arizona. So that's Idaho. We did that one the other night. So you see Idaho kind of going across over here. And, well, anyhow, I was going to show you how the same property holds true when you look under Utah here. You'll see the same sparseness through this whole desert region here. And you'll see these gold things showing up all through this. Again, this basin and range stuff in Arizona. Same property where the dark lines predict these are mountain ranges, and the flat light colored spots are the basins. And so the fringes of the mountain ranges along the basins are a good place to look, especially if you're metal detecting. And the mountains themselves are a good place to look if you're looking for lode or you're looking for tailings piles and that kind of stuff. So this is all kind of what I wanted to go over tonight in Utah. I've already outlined Texas down here, but that's Utah for now. We're about to look at Texas a little bit if people want to do that. Oops, give you a sneak peek. Spoiler alert. But I have some stuff to say about Texas that's kind of unique to Texas. So that's it for now. Let's call it a night on Utah and see where you want to go next. I'm going to go look at before I clobber this thing. Well, let's log out for now. And if you guys want to continue on with Utah, we can do so. Be glad to do that, or we can pick up Texas tomorrow. Let's see what we got. Looking at my handy dandy phone here, checking to see who's on. And and I sent out an Instagram thing showing you kind of the current status of events. We've done 14 out of 50 states. That's about 33% or so, something like that. We've got a bit more to go, but here's the sneak peek. Spoiler alert: a lot of the states don't have much gold. So what we've done is kind of divvy up east and west, bouncing back and forth. I'm going to go north and south a little bit, and then I'm going to do some other stuff to kind of give you maybe a little international feel as we get going. So right now we've got not too many people on tonight. It's kind of light night. Let's look at the comments. Let's see what we got. I have the volume all the way up and I can hardly hear you. I did it again. Doggone it. I will boost this again later. That is a problem. I did not catch that. Sorry, guys. My volume was down, and I will have to boost it after the fact. And for now, I will probably just have to pay closer attention. Yep. For all of us. Thanks for doing Utah. Marianne thought it was just me. No, it was me. Button. I need a blinking light on that darn box. I have a really neat little digitized audio box, and it has a way of putting a pad or muting me, and the problem is that's 20 dB down. That's pretty significant drop, so you'll hear it. If you turn your volume up, it shouldn't be hurting. It's enough bits that when I redo this, if you want to hear it full volume, I reprint usually about a day or two later, and it'll show up over on Prospector Jess channel on YouTube. This is an excuse for those of you from Utah or interested in Utah to go over to my Prospector Jess channel and subscribe today. So anyhow, yep, I got a few people asking for Texas, so let's do that. Okay, sticky note on the screen doesn't help because the sticky note gets in the way and then it disappears. It was up there, but it it vanished. Sad part is the interface is black button on a black background, and I don't see in out. It doesn't light up or anything. So sorry about that. That's not the first time. It's only about the second time though, but it happens. Like I said, I can recover the audio, although I just kind of made it hard because I made it loud right now. Sorry about that. So for now, let's. You guys good to go to Texas? Tell me on my handy dandy cell phone here. You just chime in right here and let me know. I got all these hearts showing up now, but I want to know what you think. Do you want to go to Texas? Do you want to see what gold is in Texas? Hint, I'm going to show you a little bit of international gold as well, because that's how you understand Texas gold best. So let me know right now. Marianne says it's good now. Andy says it's so much better. Sticky note on the screen. Yes, Marianne, I got that. Edgar says Texas. Thanks for doing Utah. Dell says, and Bob says, yes, the sound is very low. Yep, I got it. Sorry about that. And Charles, I have the volume all the way up. Yeah, I probably should have one of you guys call me or something. We could probably do that. Or I could pay attention to the comments, which I had, and then the technology. So let's break from Utah, come back right here in a minute, and we'll start up Texas. All right, see you then. Where is gold in Utah? That's tonight, and we will fix this and post it over on YouTube. I can't really repost it here on Facebook. Well, I guess I could. Comment below if you want this reposted with a fixed audio on Facebook in addition to this one. The problem is that it doesn't give you the same live love that this does, even if I don't have a lot of viewers, which I apparently lost a lot of my viewers because my voice. Go figure. I mean, people want to listen to me. So with that, it's good prospecting and good night from Utah, and join us in a minute on Texas next.